All right. Good evening, everybody. Can you all hear me? If you can hear me, please say yes. We are back with another set of sessions, this time for Hack with Infy. After your Infy TQ, we're back with Hack with Infy. How's everybody doing? How are you all doing? How's life? What's happening? Before I start the session, just want to know a little bit more from you guys, right? So how's things? How's life? How's life? What's happening? Yep. Good. Okay. Good, good. What are you guys doing? What are you guys up to these days? What have you been up to since the time from InfyTQ till now? What have you guys been up to? Okay. Have Josh Technologies interview day after tomorrow. Oh, congratulations. InfyTQ is really tough for just 3.5 LPA. Yeah, I wonder why. I wonder why you guys found it difficult. Because I saw the InfyTQ questions. I didn't think to be too difficult. I saw some of the questions, but I don't know. I think probably some of you guys must have faced the difficulty, but I felt they were not like too difficult. I saw the questions, right? I'll probably create like solutions or videos as well for them, but I just found it a little surprising that so many of you guys found it, difficult. So yeah, not sure why, but sir, I did all the codes in InfyTQ and no mail yet. Yeah, that's that's how it is right now. They'll take their time. See, guys, they're dealing with lakhs and lakhs of data. Yeah, so they'll take their time for it. You have to give them the time. Just give them some time, right? They'll take their own time to do it. So just wait for a bit. Okay. All right. I'm gonna wait like a minute before I start. Right. So I'm gonna wait like a couple of minutes before I start. All right, the session. So the third be people on YouTube. I hope you all can hear me. Please do say yes on the YouTube, and everybody please do subscribe to the YouTube channel. Let's using this placement season, let's try to make it to 40K. We're on 33K over there. Let's try to make it like 40K subscribers if possible. Amazing. Is every company is as difficult as InfyTQ exam? No, not really. Not really. It's not going to be as difficult as InfyTQ exam. I mean, not to. I don't know why you guys found it so difficult. I'll again watch. I'll again check out all of the stuff, but I don't think it was that difficult to begin with. But we have to wait and see, right? What is there? So yeah, we'll have to wait and see. It was good. Somebody saying, yeah, I think if you would have practiced well, I think this is the thing which I had warned everybody to as well beforehand. So if you don't practice, then it's going to be difficult. But if you did practice, so I don't think it's going to be like super difficult over there. Okay, cool. So sir, InfyTQ was lengthy. How to manage time and hack with Infy? Yeah, okay, I'll show you all of that stuff. So today we'll get started, everybody. So today we'll actually get started with our session right now. And just to talk about the session, just to talk about the schedule. All right, so let's just talk about the schedule right now. So this is our first class today where I'll be doing a revision of the array implementation and 2 pointers. Now, remember everybody that Hack with Infy is much more difficult than InfyTQ. It's going to be all about algorithms, data structures, and so on. A lot of the concepts we're going to discuss are going to be algorithms and data structures related, which means that it's going to be difficult. And generally speaking, those people who've taken our DSA course or who have done DSA elsewhere, you guys generally seem to do better in this course. It's generally better for the people who've done like DSA or something. But if you've not done any DSA before, then this will be very difficult, right? So this will be quite difficult if you have not done DSA before. So I'm just telling you all in advance, like, don't think that in 2 weeks you suddenly become like, great or something. But having said that, I have known people who've been able to crack even with 2 weeks of preparation. So that's the case. Now, if you know some DSA, I'm not saying you need to know full DSA. If you know some DSA, if you've done some level of practicing on DSA, then this course, the Hack with Infy 2022 preparation pack, or, whoever's attending this class, this will be useful to you guys if you've been able to understand some of these advanced concepts. So we'll start with some questions today itself, and you'll find that some of these questions today itself is going to be a little bit difficult. Somebody saying, what is the use of HackWithInfy? So use of HackWithInfy is you can actually get placed at Infosys for anywhere between 6.5 to 9 LPA. But coming back, so it's going to be difficult, and this is the course schedule. Today's session is, there. We're going to start the session in about 2 minutes. But also to everybody watching on YouTube, today's session we're doing it on YouTube as well. But if you guys do want to join this, set of sessions that we're going to do live, so all the remaining ones are going to happen on the Edyst platform only. So you're not going to get too many sessions on YouTube because it's an entire batch, and this batch will be held by both me and Devang. So we have this thing coming up. So if you guys if you're already part of a partnered college, don't worry anything about this. But if you are somebody who's not yet signed up on our HackWithInfy course and you're just trying to just watching this YouTube video, just letting you know that if you want a comprehensive HackWithInfy solution, or you basically just want to prepare for HackWithInfy, check out the link in the description below and you will get all the details of this batch. This batch has already started. It's starting today. And yeah. So will the recording of the session be mailed to us? The recording is available for everybody on the Edyst platform itself. So you don't need to actually wait for the mail. As soon as the session is over, wherever you're watching this, automatically over there, you will be able to see the recording, right? Okay, cool. So this is the case, and we're going to start with a very basic version of HackWithInfy. This is probably the easiest classes or the easiest questions you're going to do of HackWithInfy, and that they themselves will be a little bit difficult. So just letting you guys know. Of the overall concepts in HackWithInfy, there are basically implementation questions. So if you guys remember, especially from the DSA people, if you remember, we always start with implementation questions. Simple implementation, basically just implement the logic that is given as much as possible. So you'll see implementation questions today. You'll see math questions coming up pretty soon. And HackWithInfy loves primes and modular arithmetic and so on. Then there is 2 pointers, prefix sums, binary search. So we'll do a 2 pointers question as well. But this itself will cover probably 2 out of the 3 questions of HackWithInfy. So roughly about 2 out of the 3 questions should be in this. The second question could be, first question will definitely be from this. Second question could be from this, or could be from, let's say, arrays or data structures. And then backtracking, dynamic programming, graphs or trees. So this usually comes in the third question. Trees and graphs are very, very rare. So we'll do them just for for the sake of doing, but it's super rare. If I were to spend time, I would spend most of my time on backtracking, dynamic programming for the third question. So for those of you who don't know, HackWithInfy has 3 questions overall. The easy, medium, and difficult. They will not be in that order. So you have to just read all the questions and figure out which one is easy, which one is medium, which is difficult, because they're not going to be in the order of easy, medium, difficult. They're going to be jumbled also. Okay. Cool. So there will be 3 total questions. That's it. So there will be 3 total questions. And if you guys want a more detailed thing, you can just go and check out on our YouTube channel itself, roadmap to HackWithInfy. I've discussed all of these things. So I don't want to spend time today in our class to talk about this. Just check out our YouTube channel on free. It's written roadmap to HackWithInfy, where the total number of questions, preparation strategy, everything else is mentioned over there. That it's a good 1-hour session. So you'll get the entire details of, what's there and what's not there. Do check that out. That will be a much better thing for you guys, as opposed to checking, as opposed to me answering all of the questions again over here. Okay, cool. So we'll start today with 2 simple problems. Okay, we're going to start with 2 simple problems today, right? And our aim will be, there is one question called as largest index difference of something. Like there's a particular thing. So I'll show you how that's done. And the second one we'll do is efficient janitor. Okay, today. And if we have time, we'll pick up one more question that you guys want us to do as well, right? So we can do that as well. All right. The question today will rely on the concept of implementation. So all the DSA students, all the people who've done that, do you guys remember what DSA and what are the total types of algorithms that you can get in arrays? Do you guys remember what are the type of algorithms that you can generally receive in arrays? Okay, prefix sum, very good. So prefix sum is one type of a thing. 2 pointers. Okay, superb. 2 pointers. So prefix sum slash Cadane's algorithms is kind of the same thing, right? I'll go right. Window sliding, yeah, that's there as well. Sliding windows. I'll just skip that for now, just a little bit. Yeah, okay, very nice. So there's binary search as well, but these both work only if it's sorted. If sorted, I can apply binary search or 2 pointers, right? I can apply these two only if it's sorted. If it's not sorted, I might want to sort the array and do this. That's also an option, right? I could do that. Okay, there's also, before all of this comes, there is also implementation. So implementation questions are basically, there will be a particular thing asked and you just do the logic. There is no specific way of optimizing it. There's no algorithm that will optimize it. It's just simply do the logic that has been asked of you. You can get optimizations mainly based on your programming tricks, not so much on using a specific algorithm, right? So the optimization will not come on, let's say, using bit manipulation or using or using, let's say, binary search, or using dynamic programming. That's not what the optimization is going to come from. So that is what we'll call as implementation. Now, beginning with that itself, I'll just pick up the first problem, and this is all on the Edyst platform. Just give me 1 second. Let me pick that up. Right. So this is in this section. If I go to, let's say, arrays, and we'll look at this largest index difference of decreasing elements. So this is largest index difference of decreasing elements. Okay. Asked like a couple of years back in HackWithInfy. So by the way, all the questions on Edyst platform for HackWithInfy are all previously asked. So if you're finding difficulty in this, as somebody is asking on the chat, what is the difficulty level of HackWithInfy? Well, just find out yourself, right? As we do the questions, you'll kind of figure out what's the difficulty level. Okay. So screen not visible. I think it is. Can everybody just tell me if the screen is visible or not? Right. Okay. I'll just zoom in a little bit. Okay. Can questions repeat in HackWithInfy? No question will ever be repeated in any coding contest. It's never going to happen. The question will be repeated. But what will happen is a similar question will show up. So once an algorithm has come earlier, it's good to revise it because it's a similar thing that can come up later. Okay. Word for word, that same question I don't think is ever going to come up. It happened once in code beta. If I'm being very honest, it did happen once in code beta, and it was very interesting. Everybody started messaging the senior, sir, please share the code that you typed last year. So that happened. So be in touch with your seniors, everybody. That's a fun thing. Or sign up on Edyst. We have all the previous year's questions, whichever you find better. Okay, cool. So let's get started with this question. Given an array of n numbers, find the largest difference in starting and ending indexes of the elements of a possible strictly decreasing sub-arrays in the array, of all possible strictly decreasing sub-arrays in the array. Okay. So example, input 21, 13, 18, 10, 7, 3, 1. And output is 4. Okay. Why is that the case? Because if I look at the strictly decreasing elements, so if I just open this here as well, just take this here. If I take the strictly decreasing sub-array, so what is meant by sub-array, everybody? Can anybody tell me what is meant by a sub-array? What is meant by a sub-array, everyone? A part of the main array. Very nice. It's smaller part of the main array, and mainly speaking, it's a continuous part, right? Continuous segment in an array. Absolutely correct, Abhinav. Superb answer. So I cannot, for example, take 21, 18, and 7 and call it a sub-array. That would not be a sub-array. Okay, so it has to be a continuous part of the sub-array, right? So for example, now what they are saying is all of the possible, what are they asking? All of the possible decreasing, and that also strictly decreasing sub-array. So I want all of the possible strictly decreasing sub-array. So for example, if I take the indexes 0, 1, 2, 3, 4, 5, 6. So of all the possible strictly decreasing sub-arrays, I want the one which has the largest index difference in the starting and ending indexes of the elements. Largest index difference. So for example, if I look at the decreasing sub-array, I have 21, 13, but then 18 is not part of that sub-array. Then I have 18, 10, 7, 3, 1. Right? I also have 10, 7, 3, 1. I also have 7, 3, 1. I also have 3, 1. Right? And I have 1 on its own. I don't know if you're supposed to take individual elements or not. So that's a good question to ask. Are we allowed to take individual sub-array? Now, what it's saying is largest index difference between the starting and ending index. So for 21 and 13, I have 0 and 1 as the indexes. Okay. For 18, 10, 7, 3, 1, I have 2 and 6 as the differences. What about 10, 7, 3, 1? It is 3 and 6. For 7, 3, 1, it is 4 and 6. These are the indexes. And 3 and 1, it is 5 and 6. All right. Are you guys getting it? What the indexes are over here? Is everybody understanding how I got 0, 1, 2, 6, 3, 6, 4, 6, and 5, 6? Okay. No? Okay. All right. Cool. Very, very simple. Very simple. What is the index of 21 over here? 0. So I'm saying the starting index of this series is 0. Ending index of this series is 1. So 0 and 1. Next, I have 18, 10, 7, 3, 1. How did I generate this subarray? That's a separate story. But I'm saying I observe that 18, 10, 7, 3, 1 is one of those subarray which starts at 2, ends at 6. So I said starting at 2, ending at 6. Similarly, 10, 7, 3, 1, starting at 3, ending at 6. Now are you guys understanding this part? Okay, the people who said no, is that clearer for you guys? Okay. So the question is, I don't want to just generate all the subarrays, rather of all of the strictly decreasing subarray. By the way, what is meant by strictly decreasing? What is meant by strictly decreasing? Okay. Strictly decreasing means that if A, B, C are in a subarray, strictly decreasing would mean that A greater than B greater than C. I cannot have a greater than equal to, right? It has to be, all has to be strictly decreasing. There cannot be an equal as well. Okay. Now somebody is asking an important question on the chat. Sir, why you did not consider 13, 18, 10, 7, 3, 1? Can anybody tell me why I have not considered 13, 18, 10, 7, 3, 1? Because it's not decreasing. 18 is greater than 13. As simple as that, right? I want a strictly decreasing one, right? 13 cannot come into that. So 13 is greater than 8, lesser than 18. It has to be A greater than B greater than C. That's the kind of sequence I need. Okay, cool. So the question is asking, what is the longest decreasing sequence? And it's basically asking the difference in the indexes. So if I had to find the difference in the indexes over here, what is the what is the largest difference over here? What is the largest difference over here? So largest difference would be 4. This would be the largest difference, right? 4, 2, 6. Okay. All right. So everybody's understood the question, right? I think it's simple enough to understand the question. Now tell me what is your approach to this? What do you guys think is the approach? You can start with the brute force, the simplest approach, and then we can go to the optimal approach. So what do you guys think is the approach of this one? Okay, somebody says compare if condition. That is not detailed enough. Tell me something. Somebody saying take 2 pointers at 0 index and at index 1. Okay, go on. Please fully form your solution and tell me. We are in no hurry. We have at least 1 hour 15 minutes more, so don't worry about that. Fully form your solution and tell me what's the. Okay. Okay, so somebody saying that. Okay, somebody is giving me an answer that generate all the subarrays. Generate all subarrays. Generate all the subarrays. For each subarray, check. So I'll generate all subarray, and for each subarray, check decreasing or not. And then finally, generate all subarrays, generate decreasing or not. Choose the longest one. Superb. I like somebody. They have also given me bullet points. This is what I like. This will help you all in interviews. If you give it bullet points, it's much better. Okay. So many people are saying generate all subarrays, pick array which is strictly decreasing, then find the one which has maximum index difference. Okay. Cool. This is one way, and it's very important for us to estimate the order over here. So what would you guys estimate is the order of this one? If I go ahead and try to generate all the subarrays, what do you guys think will be the order of this one? Yeah, so generating all subarrays would be n square, but then I would have to go and check for each subarray. I would have to go and check whether it is decreasing or not, right? So after generating the subarray, I will further check whether it's decreasing or not, and then I choose the longest one. So this becomes order n cube all of a sudden, right? Why is it order n cube? Again, because generating all subarrays n square, but for each subarray, I will further go n times again to check whether it's decreasing or not, as per what you guys have suggested. Okay, so this comes out to be order n cube, which is, I think only InfyTQ or probably TCS NQT will allow you to do n cube. I don't think any other coding contest on earth will allow you n cube, generally speaking. There are some exceptions, like you're doing matrix multiplication. What else can you do? You can at max order n 2 point something. So n cube is allowed there, but n cube definitely not happening. Like it's too much. It's in the sense that they're not going to allow you for this. So what do you guys think? Is there a better approach here? Think about it. Is there a better approach over here? Yes, we can do it in order n. Somebody saying, oh, okay, awesome. I'd love to see that. How can we do it in order n? Please do tell me. Okay, somebody's giving me the code completely. Don't give me the code. I'm not a compiler. I will not compile your code. If that works for you, great. But yeah, I'm not a compiler, so I'm not going to compile your code. You can just give me an approach. Come on, everyone. Try to give me an approach. So somebody's saying take 2 pointers, one for first index and one for last index. Okay, what next? What do I do after that? After I've taken those 2 pointers, what do I do after that? Anybody? Any thoughts? Sir, not very clear, but some sort of cadence. Think about it. See, the approaches are lying right in front of you, where if you check 18, 10, 7, 3, 1, then we are checking 10, 7, 3, 1, then we're checking 7, 3, 1, then we're checking 3, 1. Why are we checking the others? So this is the biggest hint I can give you. So we're saying we can use pair class with elements and index and place pair elements in stack using strictly decreasing condition. Yeah, we could, but how would you generate all the pairs? You would again generate all the pairs using generating all subarrays, right? Binary search, somebody's saying. So can we apply binary search here, everybody? Could we apply binary search here? No. Okay, why can't we apply binary search? Yeah, because it's not sorted. We will need sorted. Okay, super. Okay. Come on, everybody. The clue is actually right in front of you, where you see that we are doing some repeated calculations. Do you guys not see that we're doing some repeated calculations over here? Okay, so tell me this, everybody. Let's take this example only. Okay, let me just take this example. See, when I start at 21 and I go to 13, okay, I went to 13. As per what we are saying, we're going to generate all sub-arrays. So what am I going to do then? I said, okay, 21 can go to 13, right? Is there any point in checking 21, 13, and 18? Is there any point in checking 21, 13, 18, and 10? Is there a point in checking 21, 13, 18, 10, 7? Is it any use to us to check that? No, right? Further on, the moment I checked, let's say I checked 18, right? So let's say my starting point is 18. Now I want to create sub-array. I want starting point 18. I created sub-array 18, 10. Okay, it's good. 18, 10, 7, fine. 18, 7, 7, 3. Okay, 18, 10, 7, 3, 1, fine. Then should I even start a sub-array with 10? Is there any use of starting the sub-array with 10? So the best way to understand this is that, let's say, for example, you have A, B, C, D, E. Okay. F, G. Let's say something like this. Okay. Let's say I have a sub-array starting at B. And I say that for B, the furthest I can go is E. For B, the furthest I can go is E. Now you guys tell me this, is it possible that I can then get C, D, E, F, G? Is it possible to get a sub-array C, D, E, F, G? Why is it not possible to get C, D, E, F, G? Why is it not possible? G greater than F? No, I didn't say G greater than F. No. Because we already stopped before F in the first time. Exactly. What this means to say is, when I got B, C, D, E, when I got B, C, D, E, what I'm trying to say is B is greater than C is greater than D is greater than E, and we are saying F is greater than E. Otherwise, or rather, E is less than F. Otherwise, if E was not less than F, I would have continued. I would have continued over here. I stopped here because E is less than F. So if I now start at C, the furthest I can get is anyways E. I can't go further than E. Why can't I go further than E? Again, because of this. Once I face a roadblock, I cannot go further than that, no matter how far I start. So when I started B, the furthest I can go is E. That means for C, D, and E, it also is the same. The furthest I can go is E only. I can't go further than that. Does that make sense, everybody? All right. So let me just basically show you the approach. Right. Or rather, take a starting point, go as far as possible, till the array, till the sub-array is decreasing. Go as far as possible till the sub-array is decreasing. Once you stop, start the start point from next element. Meaning that over here, let's say I had F, G, let's say H, I, J, K, L, M, let's say something like this, right? Now that I stopped B, C, D at E, I cannot start with C, D, or E. I need to start with F. The only way I can actually get something here is if I start with F only, right? If I start with anything other than F, like I could start with F, or then I could start with G or something like that. But my point is, I cannot start with C, D, or E. With B, I'll go as far as possible. I'll say that, okay, so for B, I have till E. So I have till now I have B and E, right? This is one index. With F, let's say I go all the way up till J, right? So let's say with F, I go up till J over here, right? So with F, I reach up till J. Then with K, I don't know, I reach till L, and then let's say I have only M left, right? But my point is, I don't again go through the sub-array, which I've already checked once. There's no point in going through it again. Okay. Are you guys understanding this? So there is no need for, your dynamic programming, prefix sums, none of that stuff. It's just simple. You keep going as far as possible. And then when you stop, you start from the next element and keep going again as far as possible. Is this part clear, everybody? Okay. Somebody's asking, can we do like first find largest difference of indexes and check the subarray for that indexes are in decreasing or not? Okay, what will be the largest differences of indexes? Generally, it's going to be 0 and n minus 1, right? Which is basically the entire array. So, like, not sure what you're checking for over there. Are you checking if the entire array is decreasing or not? Right. So let's try it out again, everybody. Super simple question. Don't overthink it. Others, is it clear? Not clear? Because I have people on. I have a lot of people here, but you guys have to say clear. I need your response because I won't understand if it's clear or not. Okay, so I'll do this in Python. But guys, Java also, you will almost see it's like a pseudocode over here. So I'll just do it in Python. If you guys want, I'll do it in Java later, but it's a pseudocode only. Don't worry. It's like a pseudocode. So input format, the first line contains t, number of test cases. So t is equal to int input, number of test cases. And then after that, in each line, t next line contain n number of elements in the array. Now, line is contained n number of elements in the array followed by the array elements. So you have, oh, okay, interesting. They have not given, 1 second. Let me just check. Okay, so you have 6 followed by this, right? And then you have 10 followed by the number. So, okay, so let's take the array. Let's take ARR. So let's say for cases in range t, we will take about t test cases. ARR is equal to list map int input dot split. So guys, this is all just input taking part. You can ignore it if you want to or not. That's up to you. But super simple. I think you all already know this. Anyways, what he's saying is n is the first element of the array, and then we just want the elements after that. So in Python, it really does not make sense for us to take the number of elements at all because it's of no use to us. So I'll just say array is equal to this because the first element is not actually an element. The first element is the number of elements, or is basically n, the length of the array. So this is 10, which gives you 10 elements in the array, right? 6, this tells you the 6 number of elements in the array. Okay, good. So n is that, ARR is equal to this. Okay, so now what we want to do is we'll take the start point. We'll assume the start point is equal to 0. Okay, and what we'll say is max difference is equal to also 0 because we don't have any other elements right now. Right now the max difference is 0, right? Anything else they've said if it doesn't exist? Okay, so I think the max difference will be 0. Okay, now starting is equal to 0. Currently speaking, the ending is equal to ending is also equal to 0, I guess. That's what we'll have to do, right? Okay, let's just check it out. So what we'll do is while end is less than len of ARR. So we'll keep going till the end is not reached the end, basically. Okay, so we'll start at we have a particular start point and we have an end point. 1 second. End we'll keep as start plus 1, just to understand better. Right. So now if ARR end is greater than ARR of end minus 1. So if this is the case, then keep increasing the subarray. So I'll say end is equal to end plus 1, and we'll update the maximum difference also here. We'll say max difference is equal to, or rather current difference is equal to end minus start, and I'll say max difference is equal to max of max difference, comma, current difference, right? Because if this was, let's say, greater than the previous difference, it will get updated. Okay. However, if the end is not greater than the end minus 1, then I'll say else, right? else what I'm going to do is, so somebody's saying explain this end condition. All simply what I'm trying to say is, if this C is greater than B, okay, or let's say I start at 21, if 13 is greater than 21, oh no, wait, sorry, it should be the other, it should be decreasing, right? So decreasing means less than, yeah, sorry, it should be less than. So I'm saying if 13 is less than 21, if 13 is less than 21, then say, okay, end is equal to end plus 1. Now make your end go to 18, okay? So make your end go to 18. And okay, before I do that though, I should keep this like this. Yeah. Before I do that, if ARR end is less than ARR end minus 1. So let's say my initially speaking, my start is here. Right? So my start is over here and my end is over here. If 13 is less than 21, great. Take this difference. Check if the difference is greater than the previous difference. And then after that, increase the end. And we'll again check whether it is greater or not. Right? Else, if this one is not lesser than this, means that it is not decreasing, means that I'll do start is equal to end. So my new start point has to be here. End is equal to end plus 1. This is what I'm trying to do. Okay. And I'll keep going ahead. Check. In both cases, I'm doing end is equal to end plus 1. That's interesting, which is fair, I guess. Right. So, okay. And then what we do, we print max difference. Did you see? All right. So this works for these two test cases. And if I submit it, yeah, it does work for all test cases. Okay. Anybody wants any explanation on this? Any doubts? Any part of the code that you didn't get, that you didn't understand? And if you understood, can anybody tell me what's the time complexity for this approach? Order log n. Why would it be order log n? Somebody's saying order n. Yeah, it's order n, everybody, because in the worst case scenario, the end will go like, I mean, it's just till the end reaches the end, right? So you're just going through all the elements only once. You don't go through it again. So you check a decreasing sequence. If it's not decreasing, starts at the next point, and so on. So I'm never repeating any particular part of the array. I'm just finishing the array. So it's order n. Okay, clear, everyone? Shall we go on to the next question? Can you do it in Java? There is really nothing different here in Java, guys. I mean, do you guys find anything different from this in Java? It'll just be while with a bracket here instead of anything, right? I mean, I can do it, but there is really not much of a difference, honestly. Are you guys not able to understand from this? So is there any pattern to think that this question will be solved by 2-pointer? So this is technically a 2-pointer only. So it's technically 2-pointer. Anytime you have like a sequence or subarray or something, generally it is one of these, right? So it is a 2-pointer, but it's not really a sorted part, right? So that's the thing. So yeah, I would say this is like, it's not even 2-pointer actually. I just say it's implementation. That's all you're trying to do. So okay, guys, because so many of you asked for Java, here it goes. But at this level, you should be able to just understand, right? You should just be able to understand at this level whether it's just by looking at the logic, right? That's what you guys should be able to understand. Okay, cool. So I'll entertain it for this time, but I think you guys should all be at a level where you all should understand this. So yeah. Okay. So what do? We are first taking in int t, test cases. So t is equal, and we have to declare a scanner. So scanner scan equal to scanner system.in. We do int t is equal to scan.nextInt. Then for int cases is equal to 0. Cases less than t, plus plus. What do? I first take in the array as input. So I say int arr is equal to new int. So first I take n actually. Int n is equal to scan dot next int. And after doing that, I take int arr is equal to new int n. Then I do for int I is equal to 0, I less than n, I plus plus. Arr I is equal to scan dot next int. Right. What else after that? So then I'll keep like int start is equal to 0, int end is equal to start plus 1. Then what else was there? There was int max difference is equal to 0, and then I start while end less than n. Again, it's ditto the same thing, everybody. Like ditto, I'm just converting that, but it's ditto the same thing. So while end less than n, what do I do after that? I say that if if arr end is less than arr end minus 1. So in this case, okay, keep exploring further. So let's explore further. So you get n plus plus, but n plus will happen at the end. I'll say current difference. So int here, int current underscore difference is equal to end minus start. What else? Max difference is equal to math dot max. Curve difference, max difference, right? And I think I should just do this. Okay. So I took the max difference, and yeah, that's it. So I did n plus plus, and after that else, just to start is equal to end, and then n plus plus, right? And when does this even end? This entire thing. So before I exit this, I do system.out.println max underscore difference. Have I missed out anything? No, works out. Works out, right? So again, yay, I got some animation over here. Awesome. But did you guys get this part? And everybody, Java part? Anybody wants anybody wants to understand which part, understand a part you didn't get? So tell me, I'll explain that. So the start is equal to end plus 1 or end only? No, start is equal to end. It's not end plus 1. Actually, it could be end plus 1 also. Yeah, that's correct. No, it'll be end, because we have reached a point where it is no longer lesser than the previous one. So it's a new point where we will start from. So it start to be end, right? So can you explain while loop once? So which part you didn't understand? Can you tell me? Again, it's straightforward to understand. And if you didn't, then again, suggesting it's going to be difficult, because it's the first question, this is the easiest question you're going to get, right? So if loop, so first of all, it's an if condition. And what do you see from this? What do you understand from this, right? If you're not understanding, can you tell me arr end less than arr end minus 1? Why are we doing this? Can you tell me? What does this mean? Seems to be easily understandable in Java. Somebody saying, yeah, it is. Okay, so in Python, why did we do n equal to arr 0? Because they said that the given arr is there. The given arr, the first element is a number of elements. So we are not supposed to count that as part of input. We're just supposed to get the number of inputs. Somebody saying, can you explain that list map function in Python? That is how you take input in Python, right? If you didn't get that, then you do it in any other language that you're familiar with, but that's how you take input in Python array. So somebody saying, yes, why do we do this? We do this because I want to find out if the array is less than the previous element, right? So what happens if the array is less than if the element is less than the previous element? Just think a little bit on your side, on yourself. If I have A, B, C, if C is less than B, what should I do? If C is less than B, what should I do? So let's say this is my start, this is my end. If C is less than B, I should break. Why should I break if C is less than B? If this is my start, this is my end. If C is less than B, why should I break, please? Could you tell me? I should not break. I should increase the end, because now that could also be part of my decreasing subarray, right? It could be part of my decreasing subarray. Then I can go to D. I check, is D less than is D less than C? If it is, then again increase your end. This is what I'm trying to do. Okay. Yeah. So that's what we're going to take E, which is the end, as far as possible till before we break. So I'm going to try to take it as far as possible before breaking, right? That's what and if at all it's not lesser, it means that I have to start a new subarray. That's why I'm doing start is equal to end over here. Okay. Cool. If you did not understand this, please watch the recording again, because it is very self-explanatory. If you're not getting it right now, then you need to probably revise your arrays concepts again, right? Because I'm not, as I mentioned this again, this course is targeted towards people who have a little bit of DSA understanding. You'll find a little difficult if you are finding issues with this if condition over here. Okay, so just try to, I don't know, revise your arrays concepts, because you've done similar concepts in DSA arrays part as well. Okay, so moving on to the next question. Shall we move on to the next question, please? Shall we move on? Okay. All right, cool. So the next question we'll pick up is this efficient janitor. So we're going to pick up this efficient janitor over here. All right. So let's look at this question. So the question says, the janitor of a high school is insanely efficient. By the end of the day, all of the waste from the trash cans in the school has been shifted into plastic bags, which can carry waste weighing between 1.01 pounds and 3.00 pounds. Okay, so there is some decimals here. All of the plastic bags must be dumped into the trash cans outside the school. The janitor can carry at most 3.00 pounds at once. One trip is described as selecting a few bags which together don't weigh more than 3.00 pounds, dumping them in the outdoor trash can and returning to the school. So basically one trip is he picks up, I'll explain this question. He picks up one particular trash bag, goes and dumps it and comes back. So coming back also, that all is included in one trip. The janitor wants to make the minimum number of trips to the outdoor trash can. So for example, let's say this is the trash can given, and these are the weights given to the janitor: 1.01, 1.99, 2.5, 1.5, 1.01. So the idea is I pick up 1.01. Let's say if I pick up 1.01 and let's say 1.01 here, I'm totally carrying 2.02, just as an example. I can do that. The thing is, I can't carry anything more than 3 pounds. That's what it's saying. So how many trips will I need to actually go and finish off all of the waste? Okay, let's again just repeat it. So let's say you have something like this. This is all the waste that's given to you. All right. And this waste is given like this, and it's saying that so this is all the waste like given to you. And the idea is, how many minimum trips will you need such that in each trip, I don't go more than 3 kgs or 3 grams, whatever this is. I can't carry more than 3 grams. What's the minimum number of trips needed to dump all of this in the outdoor trash can? So for example, in the first trip, I can go 1.01. So let's say first trip, I take, let's say 1.01. Second trip, I take, let's say 1.99. Third, I can take 2.5. Fourth, I can take, let's say 1.5. And fifth trip, I can take 1.01. So what will I do? I'm picking a 1.01, going to the trash can and coming back, right? This is 5 trips. Can I do lesser than 5 trips, everybody? Is it possible to do lesser than 5 trips? So I did 5 trips here. Can I do lesser than 5 trips? Yeah. Okay. How can I do lesser than 5 trips? So for example, if I did 1.01 and 1.01, it's possible to do, right? Because I can take I can take up till 3 kg. I can't take, let's say, for example, I can't further add 2.5 to this because my janitor can only carry 3 kgs, but I can do this. So I reduced 1 trip over here. Can I further reduce 1 trip somehow? Is it possible to reduce one trip somehow? So we are saying 4 trips over here, but was there a possible way of doing lesser than this? Okay, somebody saying 3 trips. Okay, how would I do 3 trips? Can anybody tell me? So I can't take 2.5 and 1.5. That's what you're saying. I can't take that. Okay, very nice. So instead of doing it like this, right? Instead of clubbing first and fifth one, what I could have instead done was, I could have said, you know what? Club this one 1.99 and 1.01. What will I do? I will get exactly. So I can't do 2.5 and 1.01, by the way. That will be 3.51. I can't do that. But 1.01 plus 1.99 will give me what? What will this give me? 3, right? And 3 is possible. I can take up to 3. I can't take more than 3, but I can take up to 3. So now I no longer need the second trip, right? I no longer need the second trip. So then what I can do is this, and then I can also do 1.5 plus 1.01, like 1.01, right? So this becomes my second trip and this becomes my third trip, right? So I no longer need 5 trips. I need only 3 trips. Okay. And in all of these trips, it's the 1.01 plus 1.99. What's the thing? It is, it's 1 trip. It's less than 3 kgs. 2.5 less than 3 kg, 1 trip, 1 trip. So overall, I did 3 trips. Minimum trip. Minimum trips. 3. I can't go further than that. Okay, that is the minimum I can do. I can't go more than that. Okay. Is the question clear, everybody? Is the question clear for you guys? Okay. Now, can anybody think of the approach? What's the approach over here? Can anybody think what's the approach? How can I solve this question? Okay. Somebody saying sort array. Very nice. Okay. How would sorting array help us? Sir, any other information is in the question description? Sure. Let's have a look at it. Yeah, this is the question, that all the weights will always be between 1 and 3. All the weights will always be between, and very specifically, they will be greater than equal to 1.01 and less than equal to 3.0. Okay. And there will be, at max, there can be 1,000 weights. At max, there can be 1,000 weights. Interesting. Somebody saying, sir, if 1,000 is there, can we do n square over here? Yeah, technically you can do n square here if you would like to. If you could do n square, because n is 1,000, yes, you could do. But you don't need to. You can do in n also over here. Can use DP wheels as you'll be solving same subproblem again and again. Don't over rely on DP, man. Don't really. I would really suggest don't over rely on DP. I mean, there are times where you used to use DP, right? But this is not the time. This is not the time to use DP. There are some times it is useful, but I'll show you where it's useful. Here, you would not want to use DP. So I'm saying sort the array, take 2 pointers, first and last, check if sum is less than equal to or greater than 3. Okay, cool. Yes, you're right. So for this, let me just do a quick revision of what 2 pointers is like, because some of you might not even be on, not understand what 2 pointers is, right? So two pointers is a very famous approach in DSA. Okay, it's a super famous approach. It works on sorted arrays mainly. There are times it does not work on sorted arrays, or rather it works on unsorted arrays. But most of the time it works on sorted arrays. Now let's say, for example, I have a sorted array. Okay, so let's say I have a sorted array. Let's say like 1, 4, let's say 6, 19, 25. 29 and let's say 64, right? So this is, let's say, the array that I have. Okay, and these are the indexes that's there. Okay, now the way two pointers approach works is it uses the same thing that we discussed in the last one. Just give me 1 second, everybody. Where did that go? Yep, here we go. 1 second. All right, so right, so let's say these are the indexes, right? So the way two pointers approach works, so let's say this, I'm just diverting from our problem and going to a different problem. Let's say I wanted to find out, can you tell me if a pair exists in the sorted array? Can you tell me if a pair exists whose difference is 21? Oh, sorry, whose difference is, let's say, not 21, whose difference is 23. Is there a pair in this array whose difference is 23? The array that you see on your screen. Right. So if I wanted a pair with the difference, let's say, so what I'm looking for is a pair with difference 23, right? And that I get in 6 and 29, right? So that's a pair with difference 23, right? Okay. Now, how can I do that? There are two ways of doing this. One of the things you could do is you could just take difference of 1 with everything. So for example, I start at this point over here. Let's say I start at this point, right? And then let's say my end point is like I first start here. I check for 1, check with 4. Difference is 3. Okay, not working. Go here. 1 difference is 5 over here. Difference is 18 over here. Difference is 24 over here. Difference is 28 over here with 1, right? And then difference is 64 over here. Sorry, 63 over here. So I did not find anything with difference 23, right? I could not find anything with difference 23 over there, right? Then what do? I say, okay, let me start with 4. I'll start with 4 and 6, right? So when I start with 4 and 6, what do I get? 6 minus 4, 2. Nope. Then 9. Sorry, 4 minus 19, 15. No. 21. No, that's not what we wanted. 25, not what we wanted. 60, not what we wanted, right? So you again start at 6 over here. Okay. Now with that 6, you check here. 13, not what we wanted. 19, not what we wanted. 23, we got what we wanted. So this approach that I described, what am I doing? I'm taking every start point and trying to check each pair of the start point. What will be the order of this approach? This is not the two pointers approach, but what would be the order of the approach if I'm taking each start point with every end point? Order n square, right? And again, as with the previous question, this is going to be order n square. As with the previous question, you will realize we are wasting some things. For example, I got difference of 25 and 1 as 24. Is it possible that any number on the right side will give me a difference 23 now? I already got 25 minus 1 as 24. Is there any possibility that I will get 29 minus 1, 20, or 64 minus 1 at all as 23? No, right? Because if this minus this is already greater, this is a sorted array. Anything on the right side will anyways give me a greater difference. I am not going to get a lesser difference. So the moment I got a difference greater than the required difference, I should just shift the start point. I should just shift the start point over here. Okay. I'll shift the start point and check 4 and 25. What is greater? 25 minus 4 is 21. Okay. Still possible that if I shift this on the right side, I can get something. So I move this here. 29 minus 4, I get 25. 25 is greater than 23. So again, there's no point in going further, right? To 64 or something, it's not going to work out with 4. So I should move this left pointer forward and I will get 6. 29 minus 6 is 23. So I arrived at my answer. Basically, because the array is sorted, I can move the left pointer to decrease the difference. I can move the right pointer to increase the difference, right? And I don't need to check those differences which are anyway greater than my difference. If they're anyways greater, then just decrease the difference using the left pointer. Does that kind of make sense, everybody? Does that make sense, everyone? Can you show the questions once again? Just rewind. That's a good part. If you're on YouTube, just rewind. You don't have to worry, right? Okay. All right. So that's your 2 pointers approach. That's your typical 2 pointers approach. Now, this is not that. We're not trying to take the differences between anything. Okay. But do you notice one thing? That a bigger bag can be combined with a smaller bag. We can take a bigger bag and combine with a smaller bag. You will never combine 2 big bags. You would want to combine a bigger with a smaller bag. If I come back to my question over here, right? So, okay. Cool. So if I want to go, okay, cool. So, anyways, sorry, just for checking the chat or something. But anyway, coming back. So the bigger bag can only be combined with a smaller bag. I can't take any other bag, right? Like you can't take 2 1.99s over here, right? So let's, for example, just take this, but let's take this in a sorted order, right? So let's take this only, but in a sorted order. 1 second. So in a sorted, it becomes 1.01, 1.99, 2.5, 1.5, 1.01. So what would be the sorted order over here, everybody? What's going to be the sorted order here if I sort this entire thing? Very good. So you'll get 1.01, 1.5, 1.99, and 2. Correct? This is what I'm going to get. Okay. Now what I'm saying is I will try to take something like this. Okay. I will try to take 1.01 with 2.5. Is it possible that I can take 1.01 with 2.5? Can I take this? No, right? If my 1.01 cannot combine with 2.5, do you think any other number can combine with 2.5? If my minimum number cannot combine with 2.5, this is my minimum number. If minimum number cannot combine, is there any other number out there? Obviously, there is no number out there that can combine with it to give me a sum of 3 because it's a sorted array, right? So what I'll do is I'll say, okay, this 2.5 has to go on its own. It's one trip of its own. So now the number of trips over here, has become 1, and I will move this back here. Can I combine this 1.01 with 1.99? Can I combine these two? Yes, I can. So what I'll do is I will then say, okay, if these two can combine, let's move this one forward and let's move this one back because these two have combined. So now it's become 2 over here, right? So that's one trip. And 1.01 and 1.55, can they combine? Yes. So this comes here and this one comes here and becomes 3 trips. And the moment your left has crossed the right, you know that you've exhausted all of them. Correct? Okay. Everybody got the approach over here? Okay, super. Now, so couple of questions to ask over here. Number one, we just checked 2 pointers. Why did we not take that it's possible to take 3 elements in a trip? We directly jumped to 2 pointers because I told you you should do 2 pointers, but we didn't even check whether we can do 3 elements in a trip. Why did we not check that? Very good. So the minimum element itself is 1.01. Let's say we have all minimum, still taking 3 minimums would be greater than the maximum I can carry, which is 3 pounds. So the maximum I can get itself is 1.0. So minimum I can get is 1.01. I cannot carry more than 3 kgs. So it is not possible at all to carry more than 2 weights. It's not possible to carry more than 2 weights. At the max, I can carry 2 weights. Okay. So somebody is saying, what if it was given lesser than that? If it's lesser than that, then you have to change the approach, right? If it's lesser than that, then we have to definitely change the approach. Then it becomes a different problem altogether. I think there you might even involve like DP or something where, yeah, you will try to get like subsets, which are, if there is no limit on the number of elements you can take, you'll try to get subsets with values whose sum is less than 3. You'll try to get the maximum number of subsets whose sum is less than 3. That's what you'll try to do at that point, because at that point the combinations matter, right? So yeah, that's a different thing altogether. We'll come to that. Probably that's a good question. We'll get. But here we know exactly I can have only between 1.01 and 3. Okay. So your approach would become sort the array. Okay. Left at 0, right at end. If ARR left plus ARR right less than 3, then left plus plus, right minus minus, and trips plus plus, because these two both will come in one trip. So trips plus plus, right? Else, what do? My left cannot go. I cannot go with this left or right. So one of them has to move. Okay, one of them has to move. Either left has to move or right has to move. I'll do right minus minus here. Right minus minus, and again trips plus plus, because just for that right one, I had to do trips plus plus at this point. Okay, everybody's clear on the logic over here. So we're saying, why can't we find sum and return sum by 3 or sum by 3 plus 1 depending on sum modulo 3? But how would that help you though? Sir, if it is right plus plus correct, no, you're right, it's not correct. It should be right minus minus. Yeah. Why would sum by 3 help us at all? I didn't get you. Okay. Anyways, is everybody kind of okay with this logic? Does the logic make sense to everyone? All right, cool. So let's go ahead and try to implement it as well. Okay, I'll start with Java over here. It'll be double, right? Interesting. Okay, cool. Let's just start it. We've got Java scanner. Main public static void string. Okay. Int, this is the number of test cases or something. Okay, that's not really given. So let me just check what the input is like. Yeah, first is just the size of the array. Okay, so int n is equal to scan.next int, and we'll need a scanner also. So scanner scan is equal to new scanner system.in. Right. Post that, what do? We check for int I equal to 0, I less than n plus plus. We should also declare an array. Let's do an array list. Right. So array list integer arr equal to new array list, just so that it's easier to sort really quickly. Okay, so arr.add scan.nextInt. And how do I sort an array, everybody? Come on, Java, very quickly. Java students, how do I sort this array? Array list of double. Superb. Thank you so much. Yeah, double, not this. Should be double. And this all should be double. Thank you. Next, double. And I'll do collections.sort. Right. Okay. Now I take 2 pointers. So I'll just say int left is equal to 0. Int right is equal to n minus 1. Right. So while right greater than left. Right. So while this right is greater than left, is that correct? Greater than equal to is also fine, honestly. Yeah, greater than equal to, because we don't want the last one to be left out. Cool. And we'll do int trips. Trips is equal to 0. So what are we checking? If arr.get left plus arr.get right is less than or equal to 3.0. So if this is less than equal to 3.0, then what do? We say, okay, then you can have left plus plus, you can have right minus minus, and you can have trips plus plus, right? Else you just do right minus minus and trips plus plus. How to decide whether right greater than left or right greater than equal to left? I'll tell you why I decided it like this. So I'll just tell you in a bit. Okay, this is the case. This is the case. All right. Cool. I still think we might be missing an edge case. No. Okay. Sounds good. So then we do system.out.println trips. Okay, so this passes this test case, and if I submit it, yep, works out, right? That's a simple 2 pointers implementation. Okay, so why did I choose right greater than equal to left, and why not just right greater than left? The reason is, for example, I thought, let's say if I'm at this kind of situation, right? Or let me just show it to you here. So let's say I'm at this kind of situation where I have 1.01 and 1.5, right? So let's say this is my left and this is my right. And this is my right, let's say, okay. So now and let's say this was not 1.01, but let's say this was, 1.6, and let's say this was 1.7, let's just say, okay. So yeah, so the thing was, let's say I'm at this kind of situation, this left and right are there. Now if I did right greater than left, so this will count, right? And then what will it do? It will just be like, okay, right minus minus, right? So it goes right minus minus over here, and that's it. So till now it had some number of trips, let's say. Now left and right are equal. it would have just stopped. But somebody has to pick up this 1.6 also, right? This 1.6 trash also has to go somewhere. So till now 1.01, 2.5 were taken care of. Then when it came to 1.6, earlier this was at 1.99. Okay, great. So this one trip comes here. 1.7 is a trip in itself. Okay, cool. Let's go take that trip. But somebody has to take the 1.6 trip also, right? So even when they're equal, it means that one trip is still remaining. Right? That's why I decided not to go. I decided to go with greater than equal to. Only when I have finally discarded that one will I, now that I go back, oh, now I've discarded all the possible. Now right is less than left, hence I can't go ahead right now. Okay. Is that clear? How to know when a problem is an array list problem? So I typically try to use array list as much as possible because it's just easier to manipulate, remove element, get element, rearrange the element. It's just much easier. It's dynamic also. I don't need to worry about the size of the array and so on. So I can just append whenever I want to and so on. So I prefer that. But you could have done this with an array also. So there's not much of a difference here. Generally, when you want to just dynamically keep adding to an array, I would suggest use an array list. That's the best thing. Sir, somebody saying, sir, here we are manipulating the original array. What if they asked for, what if they asked the original unsorted array? In that case, it would have been a different problem altogether, right? It's most probably a prefix sums problem at that point when it's an unsorted array. In this case, they did not ask that. They asked very specifically the minimum number of trips. So we can take whatever we want and sort it and do it. Can anybody tell me the time complexity of this approach? Time complexity? Order n log n, why n log n? Somebody saying, could we have done left plus plus here? Yeah, you could have done left plus plus also. You'd get the same answer. Right minus minus or left plus plus, I believe you'll get the same answer. It's not going to be different there. Hold on. Why did that happen? Interesting. Yeah, then this would change, right? Well, right greater than equal to left. Okay. We could have done, yeah, you could have done left plus plus. So we just did right minus minus. No, we can't do actually. No, you can't do. Yeah, it's correct. Why we can't do left plus plus? We are okay. The reason why we are doing it like that is, see, if you look at this, 2.5 is not working. To help out, so 1.01 and 2.5 is not working. Does not mean I increase 1.6 so that it will help with 2.5. That's not the case, right? You have to do right minus minus only. This is the entire point of 2-pointer because 1.01 and 2.5 is there. If I want to have more chances, I say, okay, 2.5 cannot combine with 1.01. Maybe the previous one can. But if I do left plus plus, I'm saying, okay, 1.01 can't combine with 2.5. Let's try a greater one. That's also not going to happen. Correct? So that's why right minus minus is the correct one, not left plus plus. N log n. N log n, the time complexity is n log n because we sorted the array. So sorting array is n log n. Collections.sort was n log n over here. It will take the most efficient one, which would be merge sort in the case of Java. And it's going to be n log n. Can we take the same element twice? No, how can you? Because you took that element and you're now trying to just, I mean, you already put it in the trash bin. So how could you take that? Okay. Somebody saying, can we sort in order n? If you manage to sort in order n, I think you would get a Nobel Prize for that. So in short, there is no way you can sort in order n as of now, as is known to mankind at this point. If you do, then I'm very sure you'll get like a very great prize. You will be remembered forever in the history books. So yeah, that's there. Okay. Cool. Any doubts? So somebody sending their code and saying that I tried, it didn't work out. Just post it on the forums. Our mentors will check it out. So do post on the forums. We'll check it out, or you can reach out to any mentor as well. Sir, can you take up strong primes next? Yeah, strong primes will take up when we're doing maths questions. We'll take it up when we're doing the maths questions. So that will not take it up today, but at the maths question time, we'll definitely take it up. Okay. Any other question, everybody? Any other like sort of doubts or question that you'd want to take up right now? Okay. So a lot of people are sending their codes. Just put it. Just put it on the on like just ask the mentors or just put on the forums. We'll happily help you there. I cannot possibly go through everybody's single code and figure out right now. That's not possible at this point. But you can just put it and ask the mentors. Right? Sir, Python code. I mean, it's pretty much similar to this one. It's not at all different. So you don't really need like me to do it separately. I would think so. Okay, cool. So if you guys want it in Python, I'll do it in Python. But so if you solve 1 or 2 codes out of 3, so we'll get selected. If you solve 1.5 also, you'll get the call. 1.5 is also enough. Last year, 1.5 was also enough. It's a very difficult test. So, I mean, some people talk about like, FANG questions and so on, but HackWithInfy asks at the level of FANG. They don't pay at the level of FANG, it's a separate story, but they ask at the level of FANG, honestly. So that's how it is. So very quickly, let's do it in Python as well. So I do ARR is equal to list map, not int over here, but it would be float input dot split. Right. So that's ARR. Left is equal to 0. Right is equal to len of ARR minus 1. And as we just said, we will sort the array, ARR dot sort. So sort the array. So what do you do? While left less than equal to right, I'll keep checking if ARR right plus ARR left less than equal to 3.0. So if right plus left is less than equal to 3.0, what do? You say, okay, great. Right minus is equal to 1. This is shorthand for right is equal to right minus 1. Left plus is equal to 1. And we need trips also. So I say trips is equal to 0. And I say trips plus is equal to 1. Right? Else I just do right minus is equal to 1. And I do trips plus is equal to 1. Okay. And that's about it. And then finally, I'm just going to print trips. So that would be your Python code, I'm assuming. Something does not make sense. Into the ARR left less than equal to right. Is it giving the number of elements? Yeah, it's giving the number of elements also, right, at the start. The first things first is the number of elements, correct? Yeah. Okay. So I have to take that also. N is equal to int input. That's right. Right? Passes and passes the test cases. Yeah, I didn't take the N as input initially. In Python, it doesn't even matter because it just splits on the spaces. So it doesn't matter. So I'm saying, so these practice questions plus module and assignments would be enough. What are other things that can be done so that we are better prepared? I mean, in these 2 weeks, this is, if you're able to genuinely solve all of these, that is enough. Honestly, you don't even need more than that. Just able to solve these much also, you're enough. Okay. All right, everybody. So we'll pause here. Please take the time and prepare, practice. We'll come tomorrow with a very special question, which is on binary search. But you may not even believe it's on binary search. It's that difficult kind of a question. It is like a Google level question, honestly. This kind of a question was asked in Google first. So we'll cover this, distribute the weights tomorrow. If everything else goes well, so we'll probably do it. So distribute the weights. Quite a difficult question, but we'll try our best to finish it off tomorrow. And we'll see if there are any other questions that we can also take up at that time. Okay. Apart from that, as I've always told you, please do check out the Edyst YouTube channel because we have a bunch of questions already solved over there in terms of tutorials. Okay, distribute the weights also, the tutorial is there. So maybe I'll take up a different one, right? So I'll take up because the tutorial is already there. I forgot about that. So do watch the tutorial. But my point is that There are a bunch of questions already on the Edyst YouTube channel. Please make sure you subscribe and you just check out all of our HackWithInfy playlist. We've already done a bunch of questions, so you can go through all those questions, and prepare better from there. So I'm saying, sir, still I'm confusing which language to take. Take that language in which you have coded and which you are most comfortable with. That's the best language that you should be able to take right now. Sir, any prerequisite for learning greedy algo and dynamic programming? Because I have very basic knowledge of data structures. No, you don't actually need to know data structures to understand greedy and dynamic programming. You can go ahead and start learning it. As long as you know your arrays well, that's kind of enough. Data structures, probably dictionaries or maps, if you know, it will just help you in the implementation of DP or greedy. That's it. If you just know that, that would be a good thing. Okay. So, missing, where are the questions? The questions are available. If you're outside on YouTube, the questions are available on the HackWithInfy preparation pack. Just check out the link in the description below for all the details about the HackWithInfy preparation pack. And lastly speaking, everybody, so just can we have a quick recap of what all we have done today? Can you all give me a quick recap of what all we did today, what all we discussed? So we're saying, when will the new DSA course on Edyst open? Probably after code beta ends. We are launching one, I think, around at the end of code beta time. So yeah. Okay. Everybody quickly give me a recap. Come on. Yeah, there is that question. Yes, we started with that. Largest index difference of decreasing elements. So we started with that. What did we do after that, everybody? Yep. Yes, you're right. We did a 2 pointers revision, and then we looked at efficient janitor. Okay, so the thing with HackWithInfy questions or any such DSA question is that you should try them out yourself before coming to the session, because if you come to the session without trying out, you are going to find it like, it's like knowing the answer of a puzzle before coming to try to solve the puzzle. If you've not given it enough thought, then you'll just understand the solution to the problem, but you will not be able to identify the next such problem. Try your best to attempt all of these questions before you come into the session. And then once you come into the session, it'll just be easier for you, or you'll get more out of the session when you understand, when you go for it. That's all. So try your best to attempt these questions before coming into the session. All right. Cool. So that's it from our side. Also a small announcement. Let me just check if I can get the announcement here. So second. What will be the next session's question? Very good. So we'll do one of the array questions only, mostly binary search related questions, something like distribute the weights. So we're going to take up something like that. So I think I would just practice as many of the array questions as possible. Right. So that's the thing. DSA using Python resources. Edyst is, I think, probably Edyst Python DSA course would be a good thing. So 1 second, let me just check if I can get an announcement over here. Yeah, so there's a small announcement, everybody, from our side. I'm also just testing if I can share this announcement right now. So 1 second. Let me just put that up right now. Let me just see if this is happening. Okay, cool. I'm just sharing this right now. Hi, do you want to know how good or bad your resume is? We at Edyst are doing free resume reviews for students. Simply go to edyst.com/resume review and upload your resumes. We will do an in-depth review and tell you how you can make improvements on your resume. Go ahead and submit your resume now. Okay, cool. That's the first time I'm actually playing, and yeah, that's the first time I'm actually playing an ad within, or a video within Zoom. So just was checking if it works out or not. So yeah, that was just a small update for you all, everybody. If you want a free resume review done, just let us know. Just go to edyst.com/resume review and we'll help you out with the resume review as well. Cool. All right. So that's pretty much it from our side, everybody. Keep practicing and I'll catch you all next time then. Okay. Hope you all enjoyed this session, especially people on YouTube. If you liked it, please hit the like button and go ahead and subscribe, and all the people elsewhere as well. just go and subscribe to our channel. Would be really helpful to us and very encouraging as well. Okay. All right, everybody. So that's it from our side. Thank you so much for joining, and yeah, I'll catch you all next time. Thank you so much.